In this short tutorial, I'm going to show you how to use Leafmap to visualize open access data. For example, Overture map data and also Foursquare points of interest data through Fuse.io, the UTF. So first, you can go to the Leafmap website, and it's a relatively new package, only like probably 2 to 3 years. But it built on top of a lot of open source mapping libraries, makes it much easier to visualize and analyze data. So just go to leafmap.org, and then on the left side, click Notebooks, scroll down to find number 102, Fields, and then from here, you can right-click to open this one in Google Colab. So I have already opened this one here, and I'm going to show you quickly going through some of the use cases, how you can utilize this to do geo data visualization very easily. So first, just install the packages here, and then you can start importing the libraries. And so first, we're going to utilize the Overture's building data. So this one is already available in the Fuse.io website through the UTF. So first, I'm going to show you how we can access the data easily. We can just simply use Leafmap to create an interactive map, and then you can just simply draw a rectangle somewhere. So for example, here right now I'm in New York City, and I can just simply draw a rectangle. Then we can just run this code block. So if you don't draw anything, we use the default one. After that, we can run this function to basically turn the ROI into a geodata frame. Then we can pass this geodata frame into the Fuse UTF function. So basically, we want to run the UTF function based on this bounding box. So it'll take a couple seconds. So what it's doing is basically using the Fuse.io to actually extract the data from Overture's map data. And you can see here 7 seconds, and it's done. Now we can take a look at the geodata frame. So it's turning, extracting the data is a geodata frame. So once we have that, we can take a look at, for example, how many buildings within this bounding box. It's about 8,000 buildings. And once you have the geodata frame, you can easily just use one line of code, map.gdf. You can load this one into the Leafmap. So Leafmap built on top different mapping libraries. The default one is IPy leaflet. So, and when you just one line of code, you can specify, for example, the color and the columns like that. So now if I go up here, you should be able to see all the buildings. You can clear this drawing polygon. Now, if you hover your mouse, you will see all the buildings, right? And lower right corner here shows you basically the attribute. You can see the height information. I will show you how to visualize in 3D later, but this is super easy. Just a couple lines of code, you can extract the data from Fuse.io, and then you can plot that directly using the Leafmap mapping libraries. So this is how you visualize them in 3D. If you want to do it in 3D, 2D, previous one is 2D. So right now, I'm going to show you how to use 3D. So we're going to use a MapLibre backend. So it's also already integrated in Leafmap. So you can just very much similar, just create a map and then add a base map, for example. So in this case, we're going to select all the buildings with building height information, and you can add a couple columns. And after that, again, just one line of code. So most of the things you can do in Leafmap is adding geospatial data, vector data, raster data. It will support all kind of vector data formats supported by GeoPandas. So in this case, we are doing basically visualizing the building footprint data set. And we select all the buildings that with the building height. Then you can specify a color map. So for example, this one, I'm going to use the blue. So any color map supported by Matplotlib, you can use it here. And the key one you need to specify is extrude. So basically means you're going to actually render the data in 3D. So take a look at this one. Pretty cool, right? So it's the same data set that we extracted earlier, but right now we are visualizing this in 3D, and it's pretty easy to do. Just one line of code. You can click your mouse on the map. You will see basically the attributes. For example, the color, the height, and you can actually change in here. You can also change different classification schemes. Right now, we're just using the quantile classification, but you can use equal interval. You can customize it. I don't have time to go into the details, but if you want, you can also go to the Leafmap here. And I think I have some tutorial here. Anyway, there are a lot more information on the website. So this is how you can visualize them. And low right here, you can also see the basically the legend here. And if you drag your mouse using your the right click your mouse, you will be able to see this in 3D. And So sometimes if you want to visualize the data, for example, you want to turn the layer on and off, you can do it like this. And you can also change the opacity using the slider. It's not super smooth on Google Colab, but if you run it locally, it will be basically instant. So this is how you can change the opacity. This is how you visualize Overture data. They also recently released data by Foursquare. So it's the point of interest data, and they also logged of data in its global scale. So tens of millions of points. Similarly, we can use the bounding box that we drew earlier to extract the data from Fuse.io, and these are some of the columns. So similarly, what we need to do is this one has a lot of points. So in this case, I'm just going to sample the data, only show you 200 points. And once you have the sample data frame, then similarly, we can visualize the data in 3D or 2D. So in this case, I'm going to visualize in 2D. And so this is using a marker cluster. And this one, we're using 8 points from XY. So basically, we have the XY, the latitude and longitude column from the data frame. And then after that, you can see here, you can zoom in and you can zoom out pretty easy. You can click your mouse on any of the marker. It will show you the name, the latitude and longitude. So it makes it really easy for you to visualize any point data set. Of course, you can also visualize them in 3D, but right now, because the point doesn't really have the high information, it might not be very useful. But I just want to show you what's available. So for example, in this case, I'm visualizing the data on a 2D map, but this is using the OpenStreetMap vector tile. So OpenStreetMap just released the vector tiles a couple weeks ago. So it's much better than the raster tile format. And all the points in here, the blue points. So those are all the point of interest from Foursquare. Similarly, we can do it really in 3D. So this one here, we're also visualizing the data with the Overture Maps data. So earlier we used the one from Fuse.io, but Overture also provide the PM tiles. So actually we can use Leafmap to visualize the PM tiles. So you can load the Overture data, basically just one line of code. So if you click your mouse, you will see here, and pretty easy. And last one, if you want other, for example, vector tile, you can also use the OpenStreetMap vector tile. It's also 3D, so you can basically combine different data together and do whatever you want. So one line of code, visualize whatever geospatial data that you want. Thank you very much.
Thank you. That was a great presentation. A question for you, as somebody who is actively creating educational content for the community, I thought maybe it'd be great if you could share your perspective on the potential for cloud-native geospatial formats to help with things like efficiency and collaboration. What do you think the future of cloud-native is going to be in that space?
Yeah, cloud-native is the future. This is why it empowers all the demo that I'm showing here. Without the cloud-native, I won't be able really to do that because I won't be able to actually render, for example, all these 3D PM tiles, all the data from Fuse.io, because those are pretty much all cloud-native geo package, so you can easily retrieve the data, and then you can even use DuckDB or some database to quickly query the data and then visualize them easily. So this is really, very innovative and makes me so much easier to teach people, because otherwise to show people how to download the data, how to put it in, and usually it will not work very well in a Jupyter Notebook environment, because if you just dump all the data into HTML, it's going to become like very laggy. But right now we can load the entire, for example, Overture Maps data, PM tiles, or GeoPacket data at the global scale, and it works just fine. So yeah, it's the future. Cloud native is the future.
I agree. Thank you. I really enjoyed your presentation.